Hello, welcome. In this short video, let us look at an example illustrating how to construct the system's equation or relationship from a given block diagram. We will also verify the basic properties of the system from the derived system relation. So let us consider the following block diagram. Given the input x of t, then we have a block that has delay of 1 second. So the input is connected to this system. Then we have a multiplier. Then the outputs are connected to a squaring system. At both the top and the bottom. And then we have a multiply by 2. That is another system. Then we basically add these three outputs. That is, add the squares and subtract the 2 times the product of the outputs here. So the final output is determined by finding the square root of this sum. So this is our y of t. So input basically goes through several blocks and the transformed outputs are finally combined, and then a square root is taken to determine the final output. So let us determine the system's output. So x of t goes through a delay of 1 second. So the output is obviously equal to x of t minus 1. And then this x of t minus 1 goes through a multiplier. Next, we have another input from x of t to this multiplier. So the output at this point is the product of x of t with x of t minus 1. And then we have a multiplier, that is, we multiply with a 2, the scalar constant 2. So we have 2 times x of t into x of t minus 1. And here we have a square both at the top and the bottom. So square of x of t minus 1, that is square of the input, gives us x square of t minus 1. Similarly, at the bottom, the squaring of the original input x of t gives us x square of t. Now at this stage, we have a adder that adds both the squares and subtracts the 2 times the product. So we add these 2 squares and subtract this product. So we have x square of t plus x square of t minus 1 and minus 2 times x of t into x of t minus 1. So again, this output goes through a system that takes the square root of the input. But this one is actually equal to x of t minus x of t minus 1 whole square. So square root of this square is clearly equal to x of t minus x of t minus 1 whole square power 1 by 2. Therefore, y of t is equal to x of t minus x of t minus 1. So the system equation is y of t is equal to x of t minus x of t minus 1. Now let us verify its basic properties. Does the system depend on previous inputs? Yes, since it has x of t minus 1 in input, y of t is system with a memory. That is, it has a memory. Now let us see if it is linear. That is, when you give an input x of t equal to a times x1 of t plus b times x2 of t then the corresponding output for x1 of t is y1 of t, and x2 of t is y2 of t. Then the output for x of t, y of t is equal to, by substituting or inserting this value in x of t, we have a times x1 of t plus b times x2 of t. And for minus x of t minus 1, we have minus of a times x1 of t minus 1 plus b times x2 of t minus 1. But if you take a common in these two terms, we have a times x1 of t minus x1 of t minus 1 plus b times x2 of t minus y, x2 of t minus 1. Therefore, y of t is equal to a times y1 of t. Clearly, this is equal to y1 of t, and this is equal to this expression, this difference is equal to y2. So the output, the total output y of t is actually a linear combination of corresponding individual outputs. So the system is linear. Now we want to verify whether the system is time invariant. So consider input x1 of t equal to x of t minus t naught. Then y1 of t is given by x1 of t minus x1 of t minus 1, and by using the definition, or by using this definition, we have x of t minus t naught minus x of t minus t naught minus 1. Now consider the output y2 of t, which is equal to y of t minus t naught. But by the definition of the system, this is equal to x of t minus t naught minus x of t minus t naught minus 1. Therefore, y1 of t is equal to y2 of t. Therefore, the system is time invariant. However, the system is not invertible. That is, you cannot uniquely determine the value of x of t from a given y of t, because the output y of t depends not only on x of t but also on a previous value, that is x of t minus. So the system is not invertible. Thus, we can derive the system equation from a given block diagram and also verify its basic properties. Thanks for watching.